Many science fiction movies depict dramatic scenes of objects, including human bodies, exploding in the vacuum of space. But does this really happen? The idea that objects explode in space due to the vacuum is a common misconception. In reality, the absence of atmospheric pressure in space does affect objects that are used to Earth's pressure, but not in such a dramatic manner. When an object, such as a spacecraft or a sealed container, is subjected to the vacuum of space, the pressure inside the object becomes much higher than the pressure outside. If the object is strong enough, it will simply maintain its shape. If it isn't, it might rupture or slowly leak its content into space. For instance, if a sealed container filled with air is exposed to the vacuum of space, the air inside will try to escape. Depending on the container's material and construction, it may burst open, releasing the air. However, this is more of a venting or rupturing process rather than an explosion. When it comes to human bodies, the scenario is somewhat different. Humans are not built to withstand the vacuum of space without protection. If a person were exposed to space without a suit, they wouldn't explode. Instead, the lack of external pressure would cause the gases in their bodies to expand. While this would cause significant swelling, human skin and tissues are strong enough to prevent the body from bursting. The person would lose consciousness within seconds due to lack of oxygen and could survive for about a minute or two in the vacuum of space before succumbing to asphyxiation and decompression. The water in bodily tissues would vaporize due to the lowered pressure, leading to the formation of bubbles in tissues and blood, a condition known as embolism. While the process is certainly fatal, it is not as visually dramatic as depicted in media. In conclusion, objects do not explode in space because of the vacuum. Instead, they might rupture or vent if they can't withstand the pressure difference. The human body also won't explode but would suffer from other fatal effects of decompression. Understanding these nuances helps demystify space phenomena and fosters a greater appreciation for the science involved in space travel and exploration.